Researchers recently scanned 7,000 public AI traces and found dozens of real passwords and API keys sitting right out in the open. But these credentials weren't in the standard text answers the models provided. They were buried deep inside the encrypted reasoning blocks, the private thought processes we pay AI to generate before it speaks. This vulnerability stems from a fundamental transition in how we use the technology. AI has moved into a state of autonomous execution. Companies are now wiring these models directly into internal workflows, granting them permissions to carry out multi-step corporate tasks without a human in the loop. This map of enterprise data output shows the scale of that takeover. Within these environments, OpenAI's coding agent, Codex, now generates 64% of the combined output of Codex and ChatGPT. The majority of the work is already the product of the machine. As AI takes on the role of primary executor, these hidden leaks within the autonomous infrastructure become a central corporate risk. When credentials exist inside the thought traces of agents working on live data, the security threat scales at the speed of the software. This frictionless execution is also erasing the barrier to software creation. Lovable, an AI app builder barely 20 months old, recently reached a $13.3 billion valuation by offering what users call vibe coding. You describe a web application in plain English, and the platform builds a working version for you. This visualization represents the scale of that output. Users have already generated more than 60 million projects on the platform, and 80% of these builders are creating functional software with the specific intent to sell it. When the technical ability to write code is no longer the bottleneck, the central challenge of the industry moves. The hard part is no longer typing the syntax. The hard part is managing the sheer volume of software being produced. To handle this explosion of tasks while mitigating privacy risks, the industry is pulling computation out of massive cloud servers and pushing it directly onto local, private hardware. We are seeing this right now with Google DeepMind's SL2T model. It allows a user to sign directly into a Pixel smartphone, where the device captures the complex spatial grammar and physical hand shapes to translate American Sign Language into English text. This process happens entirely on the device. The phone extracts geometric body pose coordinates, mapping the mathematical positions of the hands and face, and then instantly discards the raw camera footage for complete privacy. Miniaturizing these models neutralizes the immediate data privacy risk. But as these local systems scale up to handle complex enterprise work, they require a new layer of hidden infrastructure to control the flow of information. Right now, agents suffer from an operational bloat called catastrophic remembering. Because it is cheap to add a rule to an AI instruction file, but costly to delete one, these files grow indefinitely because no human remembers why the rules were added in the first place. Every time an agent runs, it must process that massive, bloated instruction set. This inefficiency, combined with massive organizational adoption, has driven enterprise token consumption up 320 times in a single year. This animated flow illustrates the architectural solution, the control layer. Gateways like Cohesor act as a filter between the software and the models, compressing tokens and routing each request to the most efficient model. By matching model size to request difficulty, these gateways slash runaway agent costs by 60 to 90%. If autonomous agents are going to run continuously in the background of our lives, they have to be affordable. The survival of ubiquitous AI relies entirely on this unglamorous, invisible plumbing. But this shift carries a heavy sociological cost. There is a viral debate currently happening over the hollowing out of the middle class of software engineering, the workers whose primary role was typing code and performing basic reviews. As AI tools generate architecture faster than any senior engineer can read or comprehend, unoptimized technical debt is piling up unchecked in code bases everywhere. This is cognitive debt. It is the hidden cost that accumulates when human operators no longer understand the systems their tools produced. When understanding is outsourced along with the typing, the mid-level expertise required to catch mistakes begins to atrophy. Relying on tools we cannot personally comprehend creates fundamentally fragile systems. We are building digital infrastructure where the human at the center can no longer fix the underlying structure. In an era where a plain English prompt can generate a working application, the sheer ability to produce work is no longer a professional differentiator. Workers must prepare for a reality where they deploy systems they have never personally read. The job pivots from the act of creation to the act of verification, relying on rigorous testing frameworks to judge what the machine has built. As the machine takes over the typing, the human role undergoes a difficult shift. When production is frictionless, value is found in the one thing the models cannot yet claim, the final architectural judgment to decide if what was built is what the world actually needed.